Okay, now let's open our snot.config file. That's a backbone of this snot intrusion detection systems. This configuration file tells snot how to behave, what to detect, and where to log alerts. Let's dive in step by step. I will open the snot.config file with the help of nano editor. The top of this snot.config file contains helpful commands. This guides you in setting up your custom configuration. We will now go through each major section step by step. So here we can find the steps to create our own custom configuration. The first one, set the network variables. First we define network variables here. Home net refers to your internal network that will protect, set it to match your network IP range. Then we have a external net, usually set to any, indicating all outside traffic. Step 2, configure the decoder. The decoder process packets and prepare them for inspection. Configuring option like checksum mode, help, snot validate, packet integrity. The decoder process packets and prepares them for inspection. The third step, configure the base detection engine. This section defines how Snort searches for signatures in traffic. For example, search method. Step 3, configure the base detection engine. This section defines how Snort searches for signatures in traffic. For example, search method manifests the algorithm. You can also configure how many alerts are. Snort supports dynamic modules, allowing flexible and modular detection. Specify the path to your dynamic libraries to enable preprocessors and detection engines. So here the fifth step, configure preprocessors. Preprocessors normalize and analyze specific traffic protocols before rule evaluation. For instance, stream 5 tracks TCP streams and HTTP inspect helps detect web-based attacks. Step 6, configure output plugins. This section tells Snort how to report alerts and logs. Alert fast sends quick logs to the terminal, while logs TCP dump stores packet logs in a PCAP file format. Step 7, customize your rule set. Here you include your custom rule files. You can use official Snort rules or write your own rules in local.rules to suit your specific security needs. You can use official Snort rules or write your own rules in local.rules to suit your specific security needs. Step 8, that's customize your preprocessor. Step 8, customize your preprocessor and decoder alerts. Preprocessor and decoder rules help SNAT handles and respond to abnormal protocol behavior. These are essential for detecting subtle and evasive threats. Shared objects not rules. Shared objects not rules are compiled binary rules that improve performance and detection for complex threats. Enables this line only if you have downloaded and compiled so rules. So that's a complete breakdown of this snot.config file, from defining your network to setting up dynamic rules. Every section is crucial for fine-tuning snot detection capabilities. Always test your configuration with snot to catch errors. Now we will write our rules using our local.rules file. Now here we will create our custom snot rules, and then we will run the then it will generate then we will generate some traffic that triggers the rule. Then we will capture and display the alerts, okay, as per our signature whichever we just create in our rules file. So I will show you how to create our own custom signature or rule in snot and how to trigger and capture the alert using it. Let's get started. Now I'm opening the local.rules file to add a new rule. We will list out the files whichever are available in the rules directory. Now here we have so many rules files are available in our rules directory. So now I'm going to open the local.rules file to add a new rule. So here we have just opened our local.rules file. Now here we will create a snort rule or the signature. So as our signature syntax, we will use the attributes like action, protocol, source IP, source port number, then destination IP, destination port number, and some other message whichever we need to display once the alert got reported. So here we will create a rule first. So we will going to start with the action, that's alert. We will use a simple protocol ICMP. Then we will use external for all the outside traffic. Then we will use any for the port number. Then we have a direction attributes. Then after that we will use a home network port address, that's any we will keep. Then here we are going to keep a message that's going to display once the ICMP packet got captured. So I will keep like ICMP now. Okay, to add, now I kept for identification. Okay, so here then after that always we have to define the unique snort ID or the signature ID. So I will keep SID so we will close the bracket. Now we have created one signature in our local dot files. So generates an alert for any ICMP packet such as a ping request. The SID, that's a unique snort ID, and message is the alert message. Now we will save it with the help of Control O. Then we will hit enter. Then we will exit from that file. Then always we now make sure that Snort includes our custom rule file in its configuration. To check the configuration file, we will use a command line like a sudo snort-t console-c, then path of our configuration file, that's a etc snot.conf. Now you can check here. The snort successfully validated the configuration. Snort existing now. So the configuration file is existing in our snort.config. So now we will start to capture the packet. So run snort in IDS mode. So to use that, we will use a sudo to capture packets snort -a console. So even here you can use your own interface, actual interface, whichever interface you want to capture the packets, you can define here. Then the file path to capture the packets. Now our Snort application started to capture the packet. So I will use another operating system, that's Kali Linux, to send a ping message to Ubuntu machine. So we have started capturing the packet, right? So now let me ping our Ubuntu machine by our Linux operating system. So we will use ping and Ubuntu machine's IP address, that's 192.168.70.3. Now I will send a ping message from Kali Linux to capture the packets. So here you can find now how our actual Kali Linux sending a packet, that's a ping message, it has started to capture the packets, right? So this see the message, whichever message we have configured in our signature, the message going to display here. Well, As you can see, Snort has triggered our custom alert, custom ICMP packet detected. That's how you can create your own Snort rules and capture alerts. You can customize rules for HTTP, DNS and other protocols as well.